This is task 3, exercise 1. I'm working with a data set of 10,000 patients that have diabetes. Now I'm setting up my the libraries. Here is task A, where I upload the data set. For task B, I noticed that there are some strings. There are some columns that are strings and not numbers. So I looked at the data set as the data frame as a whole, and saw that it was only 2 columns that have strings, which is gender and smoking history. So what I done was looked at all the unique values in both columns. So I found out that there's 6 unique values for smoking history and 3 unique values for gender. So what I done was replaced all those unique values with floats. I look at the data frame again, and now it's looking a little better. Here I just look at see if I've missed anything. Look for any NaN values. I also check the target to see how much of the data set is how much people have diabetes to from people that don't in the data set. So I'll take a look at that. For C, here I've divided my the the data frame. I'm using a 70-30 split. Here as well, I was having issues earlier because I was missing a couple of things, so I decided to use an encoder to replace any string values I missed. Here I'm using a pipeline as well, which has made my code much cleaner. So testing after training, I look at 4 metrics: accuracy, precision, recall, and F1. And I look here that I was able to score high on all these metrics. I've also created a confusion table to see to just display predictions more clearly. Here as well, I wanted I also wanted to see as well what features were the most important when making a decision. So here I've implemented sharp values, and as you can see here, we see that in for predicting diabetes, we found that HbA1c is the most important factor, which is something that everyone knows. It is the blood sugar of a patient at a 3-month span. So this is a really good indicator to see how they've managed their blood glucose levels. Second is immediate blood glucose levels, which is understandable. And third, age. Fourth, gender. So very predictable here. Here now I'm using I'm making a knife bias model and doing the same thing again to see the metrics. Here I can see that that I wasn't using knife bias out. The knife bias model did not get as high as the logistic regression model. Here accuracy was at 90%, where for logistic regression it was able to get 95% accuracy. The knife bias doesn't do well in precision, but is shown to get higher than logistic regression when it comes to recall. Here I've also done a confusion table, a confusion matrix as well, to see to just get a more clearer view. It looks like the knife bias predicts, the knife bias is very positive, where it's predicting a lot of yeses more than the logistic regression. Yeah, so it's knife bias is more more likely to predict someone has diabetes when they actually don't. So yeah, for task 1, the logistic regression was able to beat the knife bias model.